Hi everyone. In today's lesson, I'm going to go through Entity Framework Core. At this point in time, I'll be looking at Entity Framework Core 2.0. What we're going to do is we're going to interact with an existing database. And the existing database is the standard sample database called Northwind. So let's start with a project. We're going to go into a working directory and create a folder for our project. So I'm going to fall into the command prompt here, and I'll create a new folder which I'm going to call Entity Framework Core Primer. And then I'm going to go into that directory. Now, to demonstrate how Entity Framework works, I'm going to go through a bunch of command line terminal examples. So I need to create a command line application, a console application in .NET Core. So to do that, I would enter the command .NET new console. .NET, I made a typo here. This will create for me a command line application. To work with Entity Framework, I need to add some dependencies. So there are two dependencies that I need to add, and these are also called packages. The NuGet package manager of Microsoft will be used to download these packages and install them into our application. So let's install two packages. So to do that, I'm going to enter the command .NET add package, and the package I want is Microsoft.Entity Framework Core.SQL Server, because I'll be working with SQL Server. If you're going to be working with another database, you might need to add another package. So this is the first package I need. The second package is pretty much the same name, but instead of SQL Server, you put tools. And that would be the tooling for Entity Framework. To know whether or not these packages have been installed and whether or not I'm ready to actually use Entity Framework, we can do a .NET restore to make sure that the dependencies are there, and we can do a .NET ef --help. If we get something displayed here, we know that the tooling for Entity Framework is there. Because if the tooling is not there, we would get an error message at this stage. Now, there is a Northwind database out there that I want to reverse engineer. So there is a command that goes like this: .NET Entity Framework DB context. And now what you enter for DB context is a connection string that it has to reverse engineer. So it would be Entity Framework DB context, and there's a command called scaffold. After this, you enter the connection string. The connection string is the information needed by your application to talk to an external database. That typically is the address of the database server, the name of the database you want to interact with, and the credentials, essentially the username and the password. So I have here the code for this particular command. I'm going to start again, paste this code. So we're using the .NET utility here, the command ef, db context scaffold, and all of this from here to here, this is the connection string. You can see here that the connection string has the server address, max.bcit.ca, the database is called Northwind, and the user ID, and this is the password. This is the assembly that it needs. The -c stands for the name of the context that's going to be created. There will be a class that will be created called Northwind context. And this class is the entry point. -o is output. So when Entity Framework reverse engineers for us a database, it's going to create a bunch of classes. And the -o is the location where it's supposed to create these classes. So basically I'm saying here my output is NW, so there's going to be a new folder called NW, and all these classes will be put in there. So let's hit enter here and see what's going to happen. So at this stage, Entity Framework went over to the database, identified all the objects in the database, especially the tables, the columns, and created for me the classes necessary for me to interact with that database. So let's have a look at these classes. Before we proceed, let's just do a .NET build. And this is just to ascertain that we don't have any errors. Now there is an error here. It's not necessarily an error. This is a warning. And the warning says, to protect potentially sensitive information in your connection string, you should move it out of the source code. So what it's saying is that at some stage it hard-coded the connection string inside one of the classes that it created. And it's reminding us that this is not good practice. Typically your connection strings, because they contain sensitive information, they should be put in a more secure place. Now let us open our application in code, and we do that by typing in code dot. I'll hit enter here. It's going to open for me my application in Visual Studio Code. Let's have a look at this folder that was created for us. So you can see under the NW folder there are a bunch of classes that were created for us. And these classes, they represent the tables in the database. The most unique of all these classes is the class called Northwind context, which is this one here. And if you look at this context class, it is really the entry point into all the other tables and all the other artifacts that might exist in a database. And when I mean artifacts, I mean not only tables, you could have views, you could have stored procedures, you could have functions, all that stuff can be accessed somehow through this context. Over here is yet another warning that really is equivalent to the previous warning that we got, saying that the connection string is hard-coded here and it shouldn't be here. We're going to ignore this for the moment. Let us try to interact with this database. I'm going to collapse this folder. We don't need even to look at it throughout this lesson. And I'm going to spend most of my time in the program.cs class here, the main class, where I have my main method. Now, if I run my application, what am I going to get? Let me go .NET run. And I suspect I'm going to get just hello world. Hello world is going to be displayed here. And where is this coming from? This is coming from the main method. Enough hello world, let me delete that. I'm going to start interacting with the database. As I said earlier, the entry point into the database is this Northwind context class. I'm going to declare it in my class. We have a problem that somehow this Northwind context cannot be found. If you hit Control dot in Visual Studio Code while hovering on this, it will help you resolve it. So I'm missing a using statement. So I'm going to select this, okay, and it's going to add a using statement in my class. This means that my context is resolved. Let me create a method that's going to retrieve for me all the data in the categories table of the database. The reason I choose the categories table because I know that it's got very simple columns and it doesn't have too much data. It's got 4 columns, this table. It's got a category ID column, a category name, a description, and a picture column. The picture column, I'm not going to be using it at all because we're in a command line application. So I'm just gonna dedicate myself to only the first 3 columns. So let's create a simple method that's going to grab and return for us all the categories in the categories table. So I'm going to create a method here called get all categories. And I'm going to iterate through all the items that are returned from that categories table. So I'm going to say var c You can see IntelliSense has indicated to me that the context object, it contains a property called categories. Context knows about all these artifacts that are in the database. So now that I have an item in the categories that I'm going to access, I can print it out. So I can go console.writeLine, and in here I'm going to display the 3 columns. So I want to display category ID followed by a tab, and then I will display category name, followed by a tab, and then category description. Okay? And at the end, I just want to create a separator. So I'm going to create as a separator just a bunch of equal signs so that it can create for me a separator. Let us call this method from within the main method. So now in our main method, we're going to call this method that we just created, that's going to go access the data in the category table and just display it here. And we're going to display 3 columns: category ID, category name, and description. Let's try it out. See if it's going to get us any data from the database. So I'm going to come here and I'll go .NET Run. And there you go. It got us data from the database. Let's step back a second here. Did we do any SQL? No. Was there a risk that there was any SQL syntax error? Because the big problem with SQL is that you might forget a single quote here. You might have made a typo with the name of a column name. And there is no syntax check when you're actually creating your SQL statement. With Entity Framework, because the tooling helps you, if you made a typo with the name of a column name or the name of a table, it will tell you during compile time. So this is really nice. Now, Entity Framework uses something called LINQ. And LINQ stands for Language Independent Queries. And this is a kind of syntax that helps you do a lot of things that SQL helps you to do. Example, if you're doing SQL, you're able to order by, you're able to join, you're able to do a where clause, you're able to do projections, those kinds of things. With LINQ, you can do that in code. So let's create another method here, and we'll call it get categories by first character. And what I want to do here is, you can see that we have two categories that start with C. We have condiments and confections. And I want to retrieve all those categories that start with C. Let's see how I can do that using code. So I'm going to create another method, and I'm going to call it get categories by first character. Okay, and I'm going to pass it a string. And I'll just say start char, starting character. Now, this is where I'm going to create a LINQ query. I'm going to use a variable query that's going to contain the results of my query. So I'm going to say equals to context dot categories, and I'm going to add a where clause here, dot where C no, this is wrong. C now you will notice that somehow when I was typing, the tooling didn't quite help me, and I made a lot of mistakes. If the tooling was able to help me, I wouldn't have made so many mistakes. And this is because if you hover over this and you do a control dot, it is saying here that it needs an assembly. It needs to import this assembly, system.link. So if I come here and I say, okay, import for me the system.link, it will import it here, and now it should do a better job. Where category name. So this is one of the problems. This shouldn't be categories, but it should be category name. So I want to get all the categories where category name starts with a C. I'm going to copy this code here so that I can go faster. So here, by the way, a small hint, if you want to auto format your code in Visual Studio Code, the keyboard command is Shift Alt F, and it reformats your code for you. So in this case, I want to go through this query object. So I'm going to replace this with query. This is the Lambda expression. It allows you to do the things that you're accustomed to do in standard SQL. So I have my where clause here. It's going to get me all the categories that start with C, and I'm going to iterate through that and display the 3 columns that I have. So going back to my main method, I'm going to comment this out, and this time I want to call this method. And I'm gonna pass it character C. Let's run this and see what happens. Okay, so now you can see I'm getting condiments and confections. So it's working. I can do a where. Now, when it comes to Entity Framework has 2 syntaxes. One syntax is called Lambda or method syntax, and the other one is called query syntax. This syntax that I showed you here, this is actually called either Lambda expressions or method expressions. So I'm going to rename this to be Lambda. Okay. And I want to do the same thing that I did here using query expressions. What's the benefit of query expressions? The benefit of query expressions is that it is really SQL-like. It looks like SQL. But it is SQL upside down. When you think of SQL, the last thing typically you enter when you create a SQL statement is the name of the table. For example, if I want to retrieve all the data from the employees table, I would go select star from employees. The way query syntax works is that the name of the table is not the last thing that you declare, it is the first thing you declare. The reason for that is if we know the table, if the tooling knows the table, then it can help you with some intelligence on the column names and the indexes and that sort of thing. So they actually reversed it. So now let us create another method here. I'm gonna copy this name here. And instead of Lambda, I'm going to call it query. And this is the query expression. I'm going to also copy the content. Now, instead of this syntax, I'm going to use a slightly different syntax, which is the query syntax, and it looks like SQL. This is what it looks like. You say from, where C dot, name, dot starts with this and this are the same. They do the same thing. One is called lambda or method syntax, and the other one is query syntax. Do the same thing. So now, if I call this method instead of the other, it should give me the same results. If I run, I should get the same results. And indeed, I get the same result. Now, let's do something different. Let's see how we can order our data. I want now to display my categories, but in descending category ID order. Let's do that. So I'm going to take this method here and repurpose it so that we can order our data in descending category ID order. So I'm going to rename this, and I say descending order. Okay? And I don't really need to pass a character. So let me delete that. And here I'm just going to say, instead of a where, I'm going to put order by. Order by, and then you have a descending property. You have an order by and an order by descending. So we want it in descending order. We can do this. Okay, so this is it. We want our list in descending category ID order. So let me call this method. And let's run it. And you can see here, my category IDs are being listed here in descending category ID order. So what have we done so far? We've learned how to do a lambda expression. We've learned how to do a query expression. We've learned how to do a where expression. And we've learned how to do an order by expression. Suppose we want to retrieve specific columns, not all the columns. This is useful if you have a table that has many columns. Every time you make a query to the database returns all the columns, whether or not you use it. In the interests of bandwidth and efficiency and performance, you should only request the columns that you need. With Entity Framework, you can do exactly that. So I'm going to come and repurpose one of these. Maybe the last one here. And I'm going to call this get categories for, let's say, get categories specific columns. If you want specific columns, you can use this dot select. Okay, and here you can say new C dot category ID, comma. So what this expression is saying is, get me only these two columns, category ID and category name. I don't want you to go and get me the description and the picture. These are two other columns in that table. In fact, up to now, even though we didn't use the picture column, it was still bringing it in. I now have an error here because I'm trying to display the description and I didn't pull it. So you can see that the tooling actually tells you that, hey, you're not going to get the description, so you can't have this. So let me delete it. Now let's call this method. And I'm getting only 2 columns. What about joins? How do you do joins? Now, there is a keyword in Entity Framework that helps you specifically do joins. But the preferred way of doing joins when you're dealing with Entity Framework is not to think joins at all. The best way is to think relationships, because when the database was reverse engineered, all the relationships between the tables were also captured in the model. So to demonstrate this, I'm going to display all the products and the category names belonging to that product. Now you have to appreciate that in the database, we have a products table and we have a categories table. And if you want to get the category name for a product, you have to join these 2 tables and you have to retrieve the category name from the category table. The way I'm going to do it now, there is that relationship that is built into the model, so you don't really need to think about the joins. Let me do for you the code here. So I'm going to add another method here, and I'm going to call it static void, and I'll call it get products by category. So here, I'm going to design my query. And this time I'm going to go against the products table. The products table. And I'm going to do a select. In fact, let me use the character P because I'll be dealing with products. So I want to specifically access certain columns. The first column I'm interested in is the product ID. The second column is the product name. The third column I'm interested in is the category name. But notice, you can't access the category name because it's not in that table. But you can access it through the category object, you see? The relationship between the product and the categories table is available through a category property that the product table has. So I can choose category, and here I can request the category name. So behind the scenes, this did for us a join. And you don't even need to think about the fact that it's a join. In fact, you're better off not thinking SQL at all and just think objects and relationships. So now let us display this. I'm going to repurpose this code here so that I can display the data. So the first thing I want to do is copy the category, the product ID, the product name, and I'll do another tab here, and the category name. So if I run this, let me just call this method. From here, from the main method. And you see, it gave me all the products, and the last column is the category name it belongs to. So it did a join behind the scenes. Another thing you can do is you can give alias names to the column name. So you're not really tied by the name of the column in the database. You might want to call it something else. So again, let us repurpose this. So I'm going to copy this last method that we created. And I will call this alias at the end. The way you alias this, you can always expand this to make it look a little bit better. I just apply an alias to these column names. So I can say, for example, this one, I want to call it ID. This one, I want to call it the product. And this one, I'll call it category. So when I display it, I have to use the alias names. So let's call this method. And let's run. We should get the same results, but we used aliases. So we pretty much looked at many ways of doing data retrieval. Let us look into how we can insert data, update data, and delete data. Because if you know how to retrieve, delete, update, and insert, you're pretty much done. So let's see how we can insert data into the categories table in the database. And you will find that it's very easy, because if you think objects and you think like the categories that are coming from the database are nothing but a collection or a list. If you're dealing with objects and you want to add something into an array or something into, say, an array list, you just call the add method of the array list to add a new record. So let's think objects, and you'll find that it's very easy. Let me create a method here for inserting data into the table. So I'm going to call this method insert category. And I'm going to add two arguments. The first is the category name, and the second is the description. Now when you're inserting a category, you don't need to specify the category ID, which is the primary key, because this is auto-generated by the database. You just need to insert a name and a description. So, how do we instantiate a category object? You do it just like you would instantiate any other object. I'm going to set its properties. Okay? So at this point, I instantiated a new category object, and I set its properties, the category name and the description. Now I can ask the context class to give me the collection of categories, and then I can add to that collection this new object that I created, new category. And now that I've added it to the collection, all I do is I say to the context, please save my changes. So this is all you need to do to insert a record into the categories table. You instantiate a category object, you add it to the collection, and then you tell the context, hey, save. Simple as that. Let's verify that this actually works. And the best way to verify it is to do the following. Let me first get all my categories. Then let me do an insert of a new category, and the name of the category, I'm just going to call it pop, and the description, I'm going to call it sprites. And then I'll display afterwards. Let's run this and see. You can see that at first there was no sprites with category ID 10, and then it added it. So I must have been testing before and I added this sprite before, but now you can see that it added yet another one. So this is actually working. Now let me show you how we can retrieve the record with ID 10 and maybe change that to something else. So the next thing we want to do is an update. Let me come down here and create another method. I'll call it update category. Now when you update a category, the quickest way to get the category is by primary key. So my first argument is going to be the ID. The second argument will be the name, and the third argument will be the description. Before you can change something, you have to get it first. And the way to get it is this. var, I'm going to say category to change. Let's call it category to update, equals to context dot categories, and I can do a find if it's by primary key. So I can say find and find this by ID. This code will find for me that record. Then I can change it. I can say category to update dot category name, for example. I'm going to assign it the name that's coming as an argument. Category to update dot description equals to DESC. And then, as we did before, we're going to say to the context, hey, save the changes. And that should do it. I'm going to call this method instead of the insert here. So I'm going to ask it to update ID 10. And I'm going to set the category name to be fruit and maybe the description to be pineapple. Okay, so let's see if this is going to work. And you can see that item 10 here has been updated. As always, the easiest thing to do is to delete. It's always the fastest, the easiest. So let's do a delete. So down here, we'll create another method. We'll call it delete category. And all we need to pass is the ID, the primary key. Now, before we delete something, we should find it first. So I can actually repurpose this code. Take this code, copy it from here, and put it into my new method. Once you've found it, just like we added into a collection, we remove from the collection. So I can say context dot categories dot remove. In fact, let me rename this. Instead of category to update, let us call it category to delete. So I want to remove this object category to delete. And just as we've done before, save changes. So let's test this out. So up here, instead of update, I'm going to do a delete. Let me delete record with ID 4. See what's going to happen. Oh, I got a horrible error. What happened? In order to find out what happened, you can go up here and read the command. It says the delete statement conflicted with a reference constraint. I expected this to happen. We're trying to delete a category that is being used by another table. And in a high-end database, there's something called referential integrity. You cannot delete something that's being used. That's why we're getting an error. But if I try, say, to delete, say, 12, okay? You see, I had a 12 there, and now I don't have a 12. So there was a 12 right here, and now there is no 12. So it actually worked. The next and the final thing I want to discuss is how do we deal with stored procedures? How do we create a stored procedure? I'm going to introduce you to something called migrations. Every time you add to the model or you change something in the model, you create what we call a migration. Suffice to say at this moment, we want to create a migration. So you're going to type in .NET Entity Framework Migrations, and you can give it any name you want. I'm going to call it SP for stored procedure _ insert category. But because I want to make it unique, there could be already a stored procedure in the database called insert category. I'm going to prefix it with my initials. just to guarantee that there is no such object in the database yet. I'll call it MZE insert category. Unrecognized argument. Okay, I must have made a mistake somewhere. I should say add. Migrations add. I missed the keyword add. What happened here is that it created for me a folder called migrations. For every entity that it discovered, it created for me a create table command. Now I really don't need this because the tables already exist. I don't need it to create for me the table. So what I'm going to do is I'm going to delete all the contents of the methods. Now there are two methods. There is one method called up and the other method is called down. So here is the up method, and if you go further down, you will see the second method, which is the down method. This is so that if you update the database, the up method creates the artifacts, the down method reverses them. As I said, I don't need to create these entities at all because they already exist. So I'm going to come and delete all the contents of the up and the down methods. And this is a long method. The up method is a long method. So I'm going to come here and delete the contents of this up method. So now really it has no contents. Save that. I want to create a stored procedure in the database. I can do that through a migration. So I'm going to paste this in here. And let me just make it a little bit prettier by moving the string inside. So if you look at this command, here I'm declaring a string. It's a simple string, a multi-line string. And it contains the SQL command for creating a stored procedure. The stored procedure is actually going to be called MZE category insert. Let me match it with the name of this class so that they're the same. It doesn't have to be. So this is the name of the procedure I want to create. It has two parameters, the category name and the description. And this is the statement. This statement simply says insert into categories, category name, description with these values. So it's using the primary key and it's just going to return that. It's not going to create a table, it's just creating a stored procedure. And this argument here that's being passed to the app method, it's saying, okay, use this to execute this query in the database. This is how you'd create a stored procedure from Entity Framework code. So after I create this, if I wanted to execute in the database, what I do is I say, okay, .NET database update. Forgot to mention EF here. This will execute that command in the database. So it applied the migration. If I go in the database, I will find that stored procedure. I created a stored procedure. I want to make sure that I can use it from my code. So I want to call it and execute it. So back in my program.cs, I want to create another method here, which which I am going to call public static void. I want to pass string name, comma, string description. So how do we execute a stored procedure? Remember that my stored procedure had two parameters. The first parameter was a name, the second parameter is a description. So you have to declare these as parameters. So I'm going to have here var parameter name equals to new SQL parameter. Now this object is not known because it has to be resolved. So if I do control dot, it knows to import this assembly. So this declares the first parameter. Let me copy this and repurpose it for the second parameter. Let this be the description, and the parameter name is description, and this will take the value of the description. Now we can execute the stored procedure. The stored procedure, when you execute it, it returns a result. So I'm going to say var result equals to context dot database. Now this one is not known because again we have to import an assembly. So all I did was a control dot on here and we import it. Now it should know it. The stored procedure that I created, let's find out what the name was. Let me go in here and then copy this name. This is the name of the stored procedure. Better copy it instead of making a mistake and then regretting that I did a typo. I'm saying, okay, execute the stored procedure with these parameters at category name and at description. Comma. So let me just expand this so you can see it. Comma, and come down here. P name, comma, P description. So this is going to execute that stored procedure. So you specify the name of the stored procedure followed by the parameters that it needs, and the parameters have to match the parameters that we specified when we created the stored procedure. So now let's call this and see if it's going to work. So I'm going to comment this out, and in here I'm going to add a name and a description. So let me say bakery, and let us say a cake. So let's run this. And I have an error. Incorrect syntax near description. Looks like I forgot to put a comma in here. So that is the problem. Let's try again. Okay. So now it looks like I have bakery cake. so it did insert it. This wraps up what I wanted to cover in this lesson. Thank you very much.